Good day and welcome back now to some model questions that we'll be handling under the topic counting, where we look specifically at permutations and combinations. So there is something that we will see. It looks a bit new, but not really. So we get a question like this. Find the number of ways the letters of the word standards can be arranged. So we see arrange. When you see arrange, it means it has to do with permutation. So this is the key word here. I talk about the latest arrangements. So this is about permutation. So I have letters of the word standard. I'll put standard here. S, T, A, N, D, A, R, D, S. If I count them, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 letters. And if we remember, we see that to rearrange 9 letters is simply 9 factorial. We already saw that. We saw for 3 letters A, B, C, there were 6 of them, and that was just 3 factorials. For 4 letters A, B, C, D, there were 4 factorial of them. That was 24. So for 9, we will get 9 factorial. But here we have to be careful. There's an exaggeration in the counting we have done that we have to learn how to solve. This letter A and this letter A are identical. When we're doing the permutation, we look at them as if they were 2 separate letters, which means if this A is now put here and this other A put here, you would not see any difference with that. So we have counted something twice that we shouldn't. So our total counts have been multiplied by 2 because the A and the A can always play around themselves in every situation. As a result, we have to take out that. So we have to reduce this with the number of ways A's can write themselves. So A, there are only 2 of them. So one A can be in front, the other A behind, but you will not make the distinction. As a result, it is not a new permutation. So we remove that. There is also the letter S. That's also repeated twice. So this S at the end and S at the beginning, if we swap them, we see exactly the same. So we also have to reduce that. We remove that as well. It means you have to go through and check. There is also D. So I have A here, S and D. There are 2 D's. So I remove that as well. You have to check, is there any other that is repeated? If it is repeated, then you have the number of repetitions factorial. So if it was repeated 3 times, then I'll divide by 3 factorial. So that we have the actual number of counts of unique permutations that you can identify. So if I look at that, those are the only possibilities I have here. So it means my number of ways is simply 9 factorial divided by 2 factorial, 2 factorial, 2 factorial. Of course, you can simplify this if you want. I'm not going to do that. So 9 factorial coming from, I ignore the fact that some of the letters are the same. I just say I have 9 of them to rearrange 9 letters. If you are taking 9 at a time, it's just 9 factorial. But if some of them are repeated, I have to reduce the number of counts. I have to check those ones and pick them out because they're no good. And I do that by division, dividing by the number of factorial times the times they are repeated. So if A is repeated thrice, for example, then it would have been 3 factorial. Let's come to a second example, question number 2. Find the number of permutations of the letters of the word classical. Here, permutation is already indicated. So we count the number of letters that are there in classical. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them. So we expect 9 factorial possible arrangements if we imagine that all the letters are unique. But behold, some letters repeat themselves. For example, C, I have 1 C here and another C there. So I'll divide with 2 because C appears only 2 times, 2 factorial. I have L here and I have another L here. So there's 2 factorial. I have 2 A's. So there's 2 factorial. I have 2 S's. So 2 factorial. Only one I is there. So that ends. So my actual number of ways is 9 factorial divided by 2 factorial, 2 factorial, 2 factorial, 2 factorial. Where they're coming from, the repetition that we have there is good to recheck your way. C here appears twice, 2 factorial. L appears twice, 2 factorial. A appears twice, 2 factorial. S appears twice, 2 factorial. 1 is just 1 factorial. You don't need to do that. So in this case, you get that form there. We go to the third one. This is an application of definition of combination here. So find the value of the integer n given that this n combination 2 is equal to n combination 3. This just requires you to remember that n combination r is n factorial divided by n minus r factorial r factorial. This is a product, so it doesn't matter. You could also have r factorial in front, it's okay. So if I do that, then n combination 2 is n factorial divided by n minus 2 factorial 2 factorial. And n combination 3 is n factorial divided by n minus 3 factorial 3 factorial. If these two are equal, so n combination 2 is equal to n combination 3, that means my n factorial all over n minus 2 factorial 2 factorial should be equal to n factorial all over n minus 3 factorial 3 factorial. The n they fall off, so actually I get the n minus 3 factorial 3 factorial is equal to n minus 2 factorial 2 factorial. I can play with this, of course. We already saw the n minus 2 is factorial is n minus 2 times n minus 3 factorial. So this is n minus 2 times n minus 3 factorial 2 factorial. N minus 3 factorials fall away and I get 6 is equal to 2 into n minus 2. If I divide that, I get 3 is equal to n minus 2. If I take minus 2, this I get 5 is equal to n. So n is equal to 5. Hope this was helpful. We are going to do more in the subsequent videos where we get into more detailed problem selection of groups. Thank you and see you soon.